All right. First of all, as usual, all credit goes to these people over here, mostly Dr. Sanchez, because this is all written by Dr. Sanchez. And with that, we're going to move on. So over here, where we went to this portion over here, this over here is not in the in this. It is a unidirectional inviscid flow, right? What does that really mean? Usually it means going to one direction like this, pushing outwards. Now, I've been wondering why it is not a function of y and z. Now, that's because nowadays we are considering Euler's equation, first of all. And when the sound speed a was introduced earlier as a useful thermodynamic variable, in the case of compressible, now here's the thing. This is no longer incompressible, which means Mach number is about zero point 0.7 and more than 0.3. 0.3 and below, it is incompressible, but above zero point 0.3, we can consider things that are slowly being compressed. And I believe 0 0.7 is the right number for something. I just don't remember what it was. But yeah. It was stated that the quantity represents the speed at which small pressure disturbance propagate relative to the flow. Now that the conservation equation has been introduced, it is appropriate to revisit this statement by considering, for illustrating purposes, the case of a unidirectional inviscid flow. Now, because now here's what I think is happening. Well, if you think about it, basically, it's there's no like basically the velocity is going this way really fast relative to everything else and try to push it off. So it makes sense if it's axial, all the v changes in the x direction. Like if you move up with the x is more like that. And that's the mindset I had when I was making this assumption over here. Now, what does that really mean? It means the pressure is in the x direction. Everything is in the x direction. Everything. Literally all of it. So that is why I think this is possible. Otherwise, I don't know why it would be like that. And this is my assumption that I had in my brain, and that's the only way I could justify it for now. Um, anyway, now we have to deal with what we call perturbation. And this thing is everywhere. Perturbation is small little things that happen, and I'm not, I will do them, but it's going to be hard for me because it's going to take a long time for me to get used to. You'll see what I mean. But I'll do my best to show it off for me to get used to. I think it's something like this plus it might be the opposite way around actually. I think it's UI and I think then it's UI because I remember doing something similar in many of my classes. So I'm hoping some of that darn knowledge goes into this and makes it easier, but might not at the same time. And then it's P. I think it's P equal PI plus PI. Oh, is it? I think I did it wrong. What did I do wrong? It is. Okay, I did it a little bit in conventional way, but it's still correct. Okay. And now we assume this and we have to get this form over here. Okay. So perturbation. All right. Let's do this. So it is uh I think it was, let me think. What did they do? The dot product that, so it's gradient. So d dx is gradient of this, and then it was then u. So we can do what I call u I plus u prime 1 density. So it's gonna be back again. It's gonna be density parentheses density I plus density I prime. And then it's gonna be dx. Okay. And then it's gonna be plus, believe it was the delta u, so it's ui plus u prime 1 divided by dx. And then it's going to be parentheses density I plus density I prime equals 0. Okay, we're getting there. Density di dt plus density I prime dt. This goes to nothing because that is simply too small. Am I correct? Is my knowledge of this correct? No, I am wrong. Why am I wrong? Because yes, okay. The do is a small perturbation. That's all we're trying to think about. And this U, that's the I, is the average, I think. So this goes to nothing and is zero. So next is plus UI density di plus density I density x plus U1 pi density I plus, and I know this is going to be zero because it's too small because of this, obviously. And for the same logic, I'm going to assume density I dui plus U1 pi dx equals zero is correct. And we shouldn't check mark that because we didn't finish it. And after that, I'm going to assume, because of last time, that this is average, so that goes away, and this goes away. Right, now everything from dot 101 b is getting back to me. di pi dt minus ui dui pi dx plus that's di du, I think is pi, right? 1 dx equals 0. No, actually, I never check if it's actually I or 1. Oh, it's just pi, not there's no one. Okay, that's fair. Doesn't matter for me. Okay, so we do the same thing with the other one, which density V. So it's going to be V I plus V pi dt plus what's the gradient? So it's going to be V. It's going to be U. So these are going to be U. I plus U pi. We already know that's going to be nothing. Parentheses, and it's going to be a delta U I plus U created, so this is going to be nothing. And then it's going to be dx plus, is it minus? Is it plus, so it's plus equal 1 divided by density dp plus p pi, so that's going to be nothing. And we know what that is, dx. So what that gives me is dvi delta t plus delta ui pi dx negative 1 divided by density d pi dx. Hopefully I'm correct about that. Perturbation. Yes. Oh, I forgot about the bottom. So bottom is 1 divided density I plus density I perturbation. If it's small, what would happen? Oh, I see. Because you can't shake it off, dominant term wins over because this doesn't mean anything. And I know this because I can use Taylor series actually. I think you use Taylor series if I remember correctly. Something like this I did in back in 20B, I think. Something about Taylor series. I don't want to do Taylor series here, so I would assume that's correct, but I believe the Taylor strategy, I'll do it. It's like 1 plus epsilon squared too much. But here is a perturbation over here. And this took me forever for me to get. Let me explain what's going on. So basically what's happening is this is taken out 1 over I, and then you get 1 over plus epsilon I prime divided by epsilon I. And this over here, if you get it into here, you realize that this is very small and going to zero. If this is going to zero, then this is left. Yeah,